Assalamu alaikum students. We're having an important question related to class 10th from electricity. What is the question? The question: find the new resistance of a wire in terms of original when it is pulled so that its length is doubled. So we have to find out the new resistance because we know when the length is changed, its the resistance will change. And here in this case, the length is doubled, and original resistance of wire is R. So we will solve it like this. We know R, which is the original resistance of wire, which equals to rho, the resistivity, L, the length, and over A, the area of cross section of the wire. Let us take initially we are having length of L, whose area is A, so that its resistance become R. Then we are having formula R equals to rho L by A. Now, what according to question, as length is pulled, as wire is pulled, what happens? So it is its length increase, but area of cross section decreases. That goes decreasing. But what is the volume? Volume is length times A. Length times the area, that is called as the volume, that remains same. So we have to use here a new logic. What? That the volume. If I will take new length, as wire is pulled so that its length increase but area of cross section decrease. Let new length be L dash and new area be A dash, so that new volume is equal to A dash L dash, because volume equals to volume is having three dimensions, the two dimensions of area and one dimension of length. As this is the wire, it's having some area of cross section A, and it was its L. Now L has been increased, but A has to be decreased. So its length then becomes just like this. It becomes a bit thinner. It becomes like this. This is A dash. Now this is L dash. But the volume remains the same. If it is empty, whatever is the water within it, same water will be remain it. If it is full, so volume does not change. So that new volume becomes A dash B dash. As wire is pulled, so that its length but area of cross section decrease. By question, volume does not change. So initial volume, which is how much? A, area of cross section 12, and the new volume, which is how much? A dash L dash. Is it so? What we have found? We have to found L dash, because we do know we have to found A dash, because we do know L dash is 2 times L. So A dash equals to AL over L dash. So which is simply AL over L dash is 2 times L, because new length which we are having, that's because L dash new length is 2 times the original length. This L and L leaves simply A dash equals to A by 2. Now on further solving it out, now let R dash be new resistance, then R dash is equal to rho L dash over A dash equals to rho. Instead of L dash we will place 2L, and instead of A dash we will place A by 2. It is simply rho 2L into 2 by A, or we will get what R dash comes out to be 2 is 4 times rho L over A. If this thing you are going to search, it will be simply the first one R, which implies R dash is equal to 4 times R. What you have to remember now, instead of this very thing, you will be having data. That's if your wire is pulled double of, if the original resistance of wire is 10 ohm and the wire is doubled, how much will be its new resistance? It is 4 times 10, that is 40. So whatever is the original resistance, that is multiplied by 4 and you will get the new resistance. That is the new resistance becomes 4 times the original, 4 times the original resistance. The new resistance becomes here the 4 times the original resistance. This is how we are going to calculate the new resistance in terms of the, or here R dash equal 4. From this equal to simply rho L by A, that is R, the first resistance, that is R. So R is equal to 4 times R. If somewhere in the question it is given that we are having a resistance wire of resistance 10 ohm and its length is, it is pulled so that its length becomes doubled, then new resistance R dash is equal to 4 into 10, that will be 40 ohm. That's all for today. Tomorrow will be with another lecture. Till then, Allah Hafiz.